All right, so this is integration by parts and some tricks. Here's the one of the examples you sent me. It is the integral of -3 sine radical x dx. And first of all, take that constant -3 out and see what we're working with. So we have the integral of sine radical x dx, which I know I need to use u substitution to solve. So first I'm going to replace u with, or excuse me, radical x with u, which makes du 1 over 2 rad x dx. So now I'm going to solve for dx. I get 2 radical x du equals dx. But we want everything in our substitution in terms of u and du. So go ahead and replace that radical x with u. So we have 2u du equals dx. Now I can go back in and replace everything using my u substitution. So we get -3 times the integral of, well, dx is equal to 2u du. So we're going to go ahead and fill that into the problem. So we've got 2u du, and then rewrite the sine radical x. That 2 can be multiplied out with the -3, which makes -6. Sine radical x is now sine u. And so now we're just integrating sine of u times u du. Okay, so from here, in order to solve this integral, we now have to use that technique, integration by parts. All right, so when we integrate by parts, we want to determine which part of my function should be u, which one should be dv. So I'm going to choose u to be that u. Now keep in mind, those are not the same u's. I'm just using u and v because those are typically the letters that we use in integration by parts. They're not the same u though, keep that in mind. So my u equals u and my du equals du. I'm going to choose dv in this case to be sine because that has a pretty easy antiderivative. It's just negative cosine. So now if you recall what the formula is, integration by parts is when you rewrite the integral as uv minus the integral of v du. So if I rewrite that, keeping in mind we still have that -6 on the outside, we're going to end up with -6 times the quantity of, well, what's u? In this case, it's that other u that we used in the substitution, times v. In this case, v is negative cosine u, minus the integral of v du. So v, again, is negative cosine u, and du in this problem happens to be du. Okay, so now we're just going to distribute the -6 and clean up some of the signs, and then go back and replace all of my u's with respect to x. So then after making that final substitution back with respect to x, we get 6 radical x cosine radical x minus 6 sine radical x, and not forgetting our constant of integration, so plus c. All right, so this is one of the other examples, the integral e to the 4t cosine of -5t dt. And we are going to start with integration by parts here. And so you want to choose wisely for your u and for your dv. I'm going to choose e to the 4t to be u, just because that's a pretty easy derivative to take. They're both equal, actually. You can do either one in this problem, but I chose u to be e to the 4t, dv to be cosine -5t dt. So the antiderivative of cosine -5t dt is -1/5 sine -5t. So using our rule for integration by parts, this integral would equal the integral would equal u times v. minus the integral of v du. So we get that u times v e to the 4t times negative 1/5 sine negative 5t minus the integral negative 1/5 sine of negative 5t dt. Oh, excuse me, negative 1/5 sine negative 5t times 4 e to the 4t dt. Now that 4 is a constant, so I can bring it out along with the negative 1/5, and now we have a positive 4/5 multiplied by the integral of sine negative 5t times e to the 4t dt. So carrying everything back down, we're going to do integration by parts again. And this might seem like it's going to be like a never-ending integration by parts problem where you just keep going in circles. But actually it's not. You're going to see that this is going to give us an opportunity to do something algebraically. So let's do integration by parts one more time just with this piece right here. So again, your u and your dv can actually be the same. We'll choose e to the 4t to be the u, and then the trig function to be dv. And now we can go ahead and replace everything with our integration by parts rule. So it equals u times v minus the integral of v du. Now that 1/5 is a constant, the 4 is a constant, so again we can bring the 4/5 to the outside of the integral. Oops, I keep forgetting to write the dt up there. My bad. Okay, so does that look familiar? Well, it should. It's exactly the same as the original integral that we started with. So here's the trick. We are going to be able to use that to our advantage, the fact that that looks exactly the same as the original integral. So that's why I keep writing everything down on the left side of the equation and the right side of the equation. So I'm just going to go ahead and take a moment to copy everything down. You have to stay nice and neat and organized here. So I have the original left side of the equation, and now I have everything on the right side of the equation from my initial integration by parts. And now my new portion with the new integration by parts, I'm just going to combine everything together, and then we're going to do a little algebra trick here to get our final answer. Okay, so I want to distribute that 4/5 in before I can do anything with that expression, the integral e to the 4t cosine negative 5t dt. So when I distribute the 4/5 in to that entire quantity, I'm going to get 4 over 25 e to the 4t cosine negative 5t minus 16 over 25 times the integral e to the 4t cosine negative 5t dt. I'm getting sick of saying that, so let's just call it something else. But first take notice of what we can do algebraically here. I can add that entire quantity, 16/25 times that whole integral, to both sides. Algebraically, that's perfectly fine. So let's go ahead and call this quantity y, so we don't have to keep repeatedly rewriting it and saying it. So now when I rewrite everything, that's better. Y plus 16 over 25y equals negative 1/5 e to the 4t sine negative 5t plus 4/25 e to the 4t cosine negative 5t. So all I did was add that term to the other side. So algebraically, that is all sound. And if I combine these like terms, I have 1y plus 16 over 25y. So altogether, I just get 41/25 y. Now remember what y is. Y is the original integral that we're solving for. So now again, rewriting everything. All I have to do now to solve for y is multiply both sides by the reciprocal, 25 over 41. We have just solved this problem. You've just solved the integral. You got y alone. Well, what is y? Y is the integral of e to the 4t cosine of negative 5t dt. So you just figured out the integral using integration by parts twice. So that is your little trick for this type of problem. Don't forget your plus C, constant of integration, and there you have your final answer all cleaned up.